Okay, chapter 10, section 3. Only had two consistent questions about this one. It was mostly just kind of words hard, math easy. 10.3.4 says, find the largest value of n, such that 3x squared plus nx plus 72 can be factored as the product of two linear factors with integer coefficients. That is quite the mouthful. First off, what is n? It is our coefficient of our linear term. So apparently we can factor this thing, right? We're gonna have two binomials being multiplied by each other. Ooh, product of two linear factors with integer coefficients. That's what they're talking about there. And apparently they'll make this work, right? We'll get 72, we'll get a number here, and we'll get the 3 there. What they mean by linear factors is they mean that we're gonna factor it in a way that it has x and x, not x squared or x cubed or anything. Duh. Integer coefficients, meaning, hey, if you can do it with fractions, that's cool, but we don't want fractions. Just whole numbers, basically, and they're negatives. So this will make more sense once you see it about what's going on, so that's why we're talking about it. So we want to take 3x squared plus nx plus 72 and find the largest possible value we could have for n, right there, that still makes this factorable. Well, hopefully by now you know that if it were to factor, we would get 3x and x. Because again, we're not allowed to use fractions. There's only one way without using fractions to multiply to 3x squared. 3x times x. And of course, here we need 72. So we're either going to need double positive or double negative. And because n could be positive or negative, it's hard to tell which one we might need. However, we want the largest value of n, which I'm going to take to mean they want it positive, right? The biggest positive number you can come up with is what they mean by large. So if this were double negative here to multiply to a positive 72, well, we get a really negative number there. So I think they want this, double plus. So the only numbers that could go here are numbers that multiply to 72. So let's go in order. Let's keep it consistent. So I know 1 and 72 works. 2 goes into 72 because it's even. I know 2 times 35 gets me 70, so 36 must be 72. And you can check that, right? 2 times 30 is 60, 2 times 6 is 12, 60 and 12 makes 72. Does 3 go into 72? Well, I know it goes into 60, right? I could write that up here. And then there's 12 left over. So yeah, 3 will go into both of those. Looks like 20 4 times. 3 times 24 is 72. All right, so what about 4? Well, if 2 goes into it, 4 could, and it turns out it does. Notice that this is 2 times 36. Well, we want 4. There's 4. And I can write that as 2 times 18 for 36, right? So it looks like 4 times 18 will get the job done, and that's true. 4 times 10 is 40. 4 times 8 is 32. Put them together, 72. 5 doesn't go into it because it goes into 70 and 75. 6 does go into it. And the way I know is it goes into 60 and 12, right? So if it goes into 60 10 times and 12 twice, 6 times 12 is 72. 7 doesn't go into it because it goes into 70 and 77. 8 goes into it because I know that 8 goes into 80. 8 times 10, right? And that's just 1 less 8 than 80 has, right? It's 72. It's 1 less 8. So it must be 9 eighths. Get you 72. 9, of course, goes into it, but we already got 9. So here are all our options. There's quite a few. And remember, what we want is we want to make this as big as possible. So probably we want to put a number here that's going to get hit by 3 that's going to be really big. And we want to choose numbers from here that are pretty big as well, right? So what ones do we want to do? Well, we could just guess and check. But the first one I'm going to try, I think, is 1 and 72. If I put 72 there and 1 there, that's going to be the biggest possible way I could make this huge with 1 and 72. If I put the 1 there, I'm only getting 75. But if I put the 72 there, I'm getting 216. So let me say it again. Yeah, 216. Yeah, 216 plus 1. So 217 is our record right now for n. Can we make it bigger than 217? Well, if I put, let's try the next one, 36 and 2. Well, I definitely want the 2 there and the 36 here. That's going to get us 90 and 18, which is 108, plus 2, and not even close. 3 and 24. Yeah, it looks like this is going to be our biggest, right? Because we want to make this number across from the 3 as big as possible. whatever goes here won't really matter that much, right? So it looks like the biggest possible n we can get is 217. So let's go back and read the directions just so you can see what it means. Find the biggest number for n so that we can factor this, right? So we need numbers that'll work. Well, they got to multiply to 72 if it's going to work with that. And it wants to be the product, two things multiplying, of linear factors. That's linear, with integer coefficients, meaning that we're not using fractions here. So yep, looks like 217 is as big as possible on that one. 1036. This one had a lot of questions, and we did talk about it a little in class. This is one of those ones where if you just try it and you guess and check, you'll probably learn something. That's what I like about this book, the spicy problems. If you just use what you know, you can figure out what you don't know. Well, if it does factor, and I would love it to factor because that'll make it easier to solve, I'm definitely going to need 2x and x. That's going to be the way to get me 2x squared. And of course, if I got a plus 9 here and a positive 7x root 3, I'm going to need double positive, aren't I? Right? Two positives will multiply to a positive, and they'll add together to be this. Now remember, because we have a 2 here, you're going to double whatever's here before you add it up with this to get 7x root 3. Oftentimes when I do this problem, I rewrite this linear term to have the root 3 next to the 7. I don't know why they write it like that, honestly. So whatever we do, it's going to add up to 7 root 3. So our numbers, after you multiply one of them by 2, will get you 7 root 3. Okay. And they'll multiply here and here to make 9. Well, there aren't that many ways to multiply to 9. However, none of them are going to get you a root in them, right? 3 and 3, 9 and 1, none of those are going to have a root magically appear. So we know that we need a way to multiply to 9 that has a root 3 in it. We need a root 3. In fact, both of our answers are going to need a root 3, so that when they add together, we'll get 7 root 3s. That's what this means. There are 7 root 3s. So right now, if I just look at what I have, I've got 2 times root 3, so that's 2 root 3s. And I've got root 3 times x, which is just another root 3. And so right now I add up and I get 3 root 3s. So not the 7 root 3s I needed, but that's okay because this doesn't even multiply to 9 yet, right? Root 3 times root 3 is just root 9, which of course is just 3. So starting out, I've got my roots, right? I just need to make that a 7, and I need to make this, when they multiply, actually get us 9, not 3. So how do I do that? Well, let's see. If one of these had a 3 next to it, like this one right here, then when I multiply these two together, I don't do root 3 times root 3 to get root 9. I get 3 times root 9. And of course, what will that get us? Well, 3 times root 9 is just 3 times 3. That gets us our 9 that we need. Not only that, when I times this by 2, I'm not going to get 2 root 3s anymore, right? Before I got 2 root 3s. Now I'm going to get 6 root 3s. So that when I add that other root 3 to it, I get 7 root 3s. So this is our proper factorization. And the key is to eliminate the stuff that's obvious, right? We need 2x and x. Got it. It's got to be double positive. Totally. It's got to have a root 3 in it. Has to. Otherwise, I'm never going to get a root 3 here. And then from there, I kind of experimented to figure out what could I do to make these numbers work. And it is a spicy problem. It is a tougher problem. But hopefully, using what you know about roots and factoring, this wasn't too bad once you saw it. Now to find our answers, right? Because we want to find the roots of the equation. Well, one of them is definitely the negative version of 3 root 3. Because if we plug it in here, if we add 3 root 3 to it, well, anything with adds to its negative is going to be 0, right? So 0's here, don't care what happens here, because 0 times anything is 0. The other one is definitely going to be a negative answer, right? I need it to be negative root 3 here. But if I just plug in negative root 3, I'll get 2 negative root 3's plus root 3. That won't work. So what do I times by 2 to get negative root 3? This number. If I times this by 2, the 2's divide out. I get negative root 3 plus root 3 is 0. I also plug it in here, but who cares what happens here? 0 times anything is 0. So there are 2 answers. Again, the only problems that people had on this one, it seemed, the only questions they asked about were these spicier ones. So if you're having more basic questions about this type of stuff, I would encourage you to go look at the earlier material, or perhaps make sure you get this stuff tried in class. That way you can ask the questions about the more basic ones. But anyway, that's it for section 3. Another video coming.